Hey everybody! This short crash course will give you an idea of what a HAZOP is. We will talk about the 6 steps in a HAZOP and how to achieve good decisions. Whether you are a facility engineer tasked with the management of change, a process engineer getting ready for the next big project, or a project manager trying to advance a project into construction, this course is for you. You will learn about the decision-making process used by the best companies. Stick with us. Let's start off with the basics. HAZOP stands for Hazard and Operability Study. This methodology originated in the UK back in the 1960s to examine the risk of failures. After several major industrial accidents, such as the Flexborough disaster in the UK, which resulted in the loss of 28 lives, people started thinking about better ways to design facilities and understand risk. Instead of waiting for an accident to happen, a HAZOP can be done to identify and assess hazards. First, we need to understand what risk is. This seems to be straightforward, but the word risk can actually mean different things to different people. So, how do we define risk? In essence, there are 2 components of risk. That's it. As long as you have the decision criteria of these 2 components, you can make any risk-based decision. The first component is probability. This expresses the uncertainty of future events. Think of flipping a coin. What is the uncertainty of the outcome before and the uncertainty after the result is revealed? The probability of 2 possible outcomes is 50% before, but 100% after. What changed? The state of knowledge. Probability is the expression of uncertainty. The second component is consequence. This is important because without consequence, there is no risk. Consequence is something that matters to you or your company. What are some consequences you care about for your next project? So you have been invited to HAZOP with a bunch of people. But why? Because high-quality decisions require shared perspectives. A HAZOP is a process to identify risk through a creative and collaborative process. This is done on the collective knowledge of a multidisciplinary team. The 2 key sets of knowledge are engineering and operation, but they do not always agree. This is where a facilitator comes in and acts as a decision leader. With the right tools and approach to guide the team, high quality and rational decisions are achieved. The facilitator applies a decision process which is simple enough so everyone can understand, yet comprehensive enough to address all risk. Let's break down a HAZOP into 6 steps. Step 1. Identify the risk by asking what can cause a hazardous event. This can be overwhelming since a process can have thousands of causes for hazard. The risk identification process can be made more systematic by thinking of specific process deviations. Here are some examples of process deviation: high temperature, high pressure, low level, misdirected flow, no/low flow. By having the team focus on a specific deviation, the discussion becomes more focused and productive. Let's look at an example in the oil and gas industry. What can cause high pressure in the following process? Here you have a pressure vessel with product coming in as emulsion. This vessel has a pressure control loop and a level control loop. This vessel has a maximum allowable working pressure slightly above the pressure safety valve set point of 3400 kPa(g). Let's start off with the high pressure deviation from normal operation. Can you think of a cause? What if the pressure control valve fails in the closed position? Step 2. Describe the worst credible consequences without safeguards and assign a severity level to it. What if the vessel V100 were to overpressure leading to rupture due to inadvertent closure of the pressure control valve? Can it kill someone? Can it cause a public relations disaster? Is it going to cost thousands of dollars to fix the equipment? These may be some of the consequences that matter to you and your company, and the risk should be managed. Based on some discussion, the team has agreed a vessel rupture can lead to a fatality. Now, one of the 2 elements of risk is established. What is the other element? Step 3. Let's assess the probability of the pressure control valve failing closed without safeguards. The probability of the pressure control valve failing closed includes all possible root causes, such as logic controller or sensor output error. Based on different operating and engineering experience, there may be different opinions. Is it 10% chance in a year? 1% chance in a year? 20% or maybe 90% chance in a year? The HAZOP team needs to reach a consensus. Step 4. Once a consensus is reached, evaluate the risk based on severity and probability without any safeguards. Let's say our scenario has a high probability of control valve failure and a high severity due to possible fatality. The definition of high probability and high consequences is defined in your corporate risk matrix. Look up your risk matrix to categorize the risk. To keep this example simple, there is high probability and high severity on the risk matrix. This is considered a high risk and not acceptable. What can be engineered to reduce this risk? Step 5. Now the focus is to reduce the risk by reducing the probability of the consequence. Look for the safeguards and assess the risk with safeguards applied. Is there an alarm with operator intervention? Is there a pressure safety valve on the vessel? Is there an automatic safety shutdown on the high pressure alarm? There is a pressure safety valve PSV 100 designed for this blocked flow case. The pressure safety valve will reduce the likelihood of a vessel rupture, but this will not eliminate the risk since the pressure safety valve can potentially fail. Step 6. The final step is to make a decision to accept the risk or make a recommendation to further reduce the risk. By lowering the probability using a safeguard, the risk is lowered. Your risk matrix defines the risk acceptance criteria. Depending on the risk, you may need to make a recommendation when the risk is not acceptable. Remember, there is no value in a recommendation without commitment to action. It is important that each recommendation gets buy-in from both engineering and operations. A HAZOP alone does not change your risk exposure unless there are effective actions sustainable for operation. Any questions? Contact us at www.icarus-orm.com. See you at the next course. Bye-bye. Class dismissed.